So, hello everyone. Good morning. My name is Murali Krishna Gurram. I'm a scientist, a senior research faculty at National University of Singapore. I closely work with the Ministry of Health, Singapore, in the areas of spatial information technology and applications, especially for environmental quality assessment, climate change, risk monitoring within the context of infectious disease incidents modeling, and surveillance applications. I have 23 years of experience in the knowledge domain of spatial information technology. I first started my career in 1987 as a senior research fellow with Regional Remote Sensing Service Center, Nagpur, Andhra University. And in 2004, I joined the corporate sector and served various reputed organizations in different leadership roles and capacities till my early 2019 to join the current position with NUS. So before I'm going to talk on the topic, I would like to thank Dr. Suresh Babu Garu for inviting me for this talk and to share my knowledge and views on the this particular technology. Indeed, it's a great privilege for me to talk on something which is so potential and which is it is an emerging a technology domain, knowledge and technology domain. So the title of today's topic is, as you know, location intelligence and GIS development. So the principles and applications. So in fact, before I touch the core, I'd like to speak something more on the knowledge areas, which along with in fact this along with biotechnology has been identified one of the potential and game changer technologies of the 21st century by NASA USA. So before before actually we dive deep into the the core presentation, we need to I feel that we need a little bit of intro on the the background of the GIS, origins of GIS, the misconceptions or myths, whatever, and its history, which I'm sure it prepares a ground for you to understand the knowledge domain in a better context. While going through the presentation at places, you may find the content repeating, but I request you all to bear with me because I used it with this with some contextual sense only. So I don't think it is a repetition of the things. So please bear with me. So what we call today the spatial information technology, briefly we call it SIT, is in fact a broad knowledge domain. I would say is actually an art in the combination of an art, science, a tool, and a technology. It's a broad domain. It is the amalgamation of various specialized expert fields, faculties, which includes your GIS, geoinformatics, your computing, your digital image processing, statistics, data science, remote sensing, photogrammetry, LIDAR, GPS, for that matter, geography, cartography, geoscience, environment, civil engineering, etc. What you mentioned, what not, So it is actually we most of the times we refer SIT, Spatial Information Technology, as GIS, but it is actually not. GIS is part of it. Many, for that matter, even professionals today, I saw, they interchangeably they call spatial information technology as GIS. It is not it's not the fact. And the many of the professionals also carry a misconception that in fact it's a geographer's tool, and some even believe that it's a automated mapping tool, and some think that it is CAD for they think that as CAD is for civil engineers, GIS is for geographers. No. So I just while we go through the presentation, you come to know about how it is actually understood and what it is. So because all these views are, because of the limited view on knowledge of the respective, personalities or individuals. In fact, for decades, it has been understood in that way, and it has been denied, and it is being denied, actually ignored its potential use in many faculties. But because of its natural capacity and potential, it has already started transcending into the every faculty or aspect of our today, of our lives today. I'm sure this particular domain, knowledge domain, is going to revolutionize the world of information technology and computing applications in future. So, in fact, we would say, we must say a big thanks to Google for its, since its inception in the late, for the last 20 to 25 years, along its, journey. Google has recognized it and nurtured it, developed it, and revolutionized it, and contributed enormously for the development of this specific technology. And in fact, many people came to know about this particular technology because of the Google, if I'm not exaggerating. So earlier it was, it was only confined to, the few specific laboratories in, research, labs, and it is only confined to some specific faculties wherever it is, is being used. So in fact, it is, there is nothing wrong in believing that, it's actually a mapping tool, because it has its own, its roots in geography. It's initially it started its journey as a cartographer's tool for making this, map making process, automated. But it's, it's not just for, as I said, it's not just for mapping. It is much more. It's in fact a powerful tool and analytical, computational tool. So I would say that, it is, in fact, I would say SIT has, other side of the IT computing domain. So I'm not exaggerating. It is the other side of the IT computing domain. So you being, the future IT computer application professionals, so I recommend you all, all students, should start realizing and exploring the actual potential of it, what it is actually the technology is. So you may ask, if I talk like this, you may ask, if it is so that powerful, or if that potential, why aren't, we are see many SIT professionals around us, why we don't, see the educational institutions, introducing specialized, degree programs in SIT? That is, quite natural to ask. No, it's because, in my view, we are still in the nascent stages of the information age, because the potential of this technology, this particular technology, has not been utilized to its fullest extent so far. So, but you may now while going through the presentation, you may understand, how powerful it is. So, and in fact, we have not still come to a stage, where we can, actually, enjoy the full potential of, the power of, all these applications. That's the reason. Maybe, immediately you may also raise a question that, being a IT computer student, how am I going to learn all this? Because I mentioned so many faculties and technologies, which you may ask, how can I, I'm not belong to the so and so field. How can I learn all these? It is, very difficult. Let's put this way. So it's not necessary that, you should become a finance expert to manage your finances, but if you're a bit knowledgeable, definitely, so you can be a very good, you can far better manage your financial related matters. It's as good as with many other faculties. Why this so powerful? I'm talking about its potential and powerful. So we are going to discuss in the presentation itself. So if just have a look at my agenda, I'm going to talk on the introduction. I gave you already a brief introduction. Maybe some of the slides, which also cover the introduction part. And afterwards, we are going to talk about a brief of about the GIS, why GIS actually. So, and after that, how GIS, transformed into location intelligence, and how it helped, the evolution of geospatial technology, contributed for distributed and web. What is distributed GIS, and data sharing and data sources, applications, and many of the services protocols that being used, widely being used, open source resources available. And in the end, I'm going to discuss something more about what are the skills that is required for in order to become an expert in this particular aspect. And I will also for a brief point of time, I'm going to discuss about the career paths in it. Next slide, please. So as I told you, so actually let us not call this just simple GIS. We need to talk this SIT, Spatial Information Technology. So why we are referring this as GIS? It's because it most of the times it deals with the geography content, and it mostly deals with the information related to the geography. That's why we call it as geographic information systems. It's in fact as I said it's a art, science, and technology domain. Okay, so what is mapping actually? So when we talk about the spatial information technology, we mostly interchangeably we refer to maps. What these maps are actually? So maps are in fact they are the information visualization of the the information on in a space. So they are the inventory and representation of spatial phenomena. Okay, so when we talk about geographic information systems, so the it has some information behind it. What we see, in fact, what we see is in a pictorial form of representation of it. In fact, we are dealing with the data behind this. Next slide. Now, before we, we need to, as I told you that, when we talk about GIS, we are in fact referring to the spatial. So, spatial content. In traditional IT, whatever, most of the data that we deal in these, these applications today. So, the most of the databases, word processing applications, spreadsheets, whatever, everything mostly they entirely deal with the and handling they have the capability of handling the managing the data in the dimension of 0. That means it only talks about the 0 dimension, that is a property of an object, or for that matter maybe if it expanded more, it only talks about the relation between the property and an object, that is one dimension. So it is here we are going to talk about the relation, so it becomes one dimensional. So but GIS is much more powerful because it deals with the spatial phenomena, space around us. So the real world, in fact, it is in fact, what we represent here is an abstraction of the real world phenomena in the computer world, but it is actually the representation of the actual objects, real world objects, properties, elements, and the relationships, interactions, actions and events, and the processes, outcomes. Okay, so yeah, most of the times, here we are referring as we are talking about real world phenomena, 2-dimensional, 3-dimensional, 4-dimensional. I just mentioned here. What does it mean by? So when we talk about the 2-dimensional, so here we are talking about the the relations. 3-dimension talks about your third dimension, that is height, your height, because real world every object you see it has some height context. And fourth dimension is your the time. So those are very important that we cannot ignore. So that the fourth is the time. What is fifth dimension then? Fifth dimension talks about the outcomes of the interaction between these real world objects, that is some change. It talks about some change that we call as temporal. It means, so you are comparing a specific phenomena, in space, in a specific point of time to a specific point of time. So when you are talking about the interactions and the processes, certainly there would be some kind of outcome. So this particular fifth dimension talks about that. Maybe there is also a sixth dimension I am not going to talk about, but still it is under the stages of development. So which is augmented, augmented stage. Sixth dimension is augmented stage. So in a broad sense, we call all these D's as six senses of our data view, our real world view actually. So we generally we say that sixth sense. So like similarly six senses. Similarly, we also call here is the six senses of the computational or data view. Okay, so an element or a property of an object represents as I told you, 0 dimension in space. So because when it talks about its relation with some object, then it becomes a 1-dimensional. So next slide, please. So this particular slide, okay, so we have discussed what is space, spatial and GIS. So whatever the objects that are there in space, available on space, that is we refer to as spatial. Okay, location is the new champion of analytics. So it is still not recognized as we have not understood the fullest potential. Sorry. So you can see the first principle of geography here. Everything in space is related to everything else, but near things are more related than the distant things, which means so the closest things are more related. So that is why so many layers of information that we have today, we need to discuss auto discover about the relationships and providing key insights about the modeling automatically. So most of the data that we actually deal with, in fact, not even the 10 to 5% of the real world, that is there in the real world domain. So we are only dealing with the why do we deal with actually the data? What we refer to data is in fact we are referring to the data. I told you all the elements. Is that fine? Yeah. Fine. So what we refer to is is actually what the data that we use today is actually we only use for making the real world decisions. So that means, so you being a IT computers professional, there's a lot of scope for further potential opportunity for future to develop. So next, please. When we talk about the capabilities of GIS, here we are in fact referring to the capability as it has a it's ability to handle the MultiCriteria in a hierarchical view. So what we call it as MultiCriteria model. So because here in GIS we deal everything with in a layered concept, because the real world itself is a layered thing. So as I told you, the temporal. So each time we refer to as a temporal dimension, and we deal that here in the computer space, in GIS space, as a specific layer. So these analytical hierarchical process models, they in fact they identify, they help you identify, prioritize, or select or classify a phenomena based on a criteria using analytical hierarchical model, so which are highly sophisticated and powerful, and compared to any other decision science tools. In fact, these are in fact the basis for data science, what we talk about, the data science, where you have the classification, machine learning, artificial intelligence. These are all actually dependent on this premise of the MultiCriteria models. Okay, that takes into account the priorities, and these models, they diversify the alternatives, and ultimately the individual criteria translate that into a visualization or pictorial form that has a map, and predict the diverse scenarios in different location in different in real time. Okay, so you can see here, maybe you can see in the slide, you wanted to achieve some goal. So in order to achieve that particular goal, you have devised your criteria into different layers or hierarchies, so which helps you ultimately achieve your goal. Maybe on the right side, you can see the representation that in a pictorial form, how many layers of information layers that you have, ultimately the kind of filtering that is being done ultimately to achieve the desired objectives. So next. Here in this particular slide, I just wanted to show you some base simple some of those applications of this. You can see financial services, transportation, logics, government, e-governance, land administration, telecom, real estate, public health. These are all some of the application areas. Maybe you may, if I mention some of the application areas, you really wonder. They're totally unconventional sectors like history, archaeology, and polity, biology, public health, media, entertainment. These are all unconventional sectors. They are widely using this particular technology today. So you name any particular sector, you name any sector. So there is you will not find any sector which is not utilizing the the power of your spatial information technology, or the prowess of the analytical analytical capabilities. Okay, so I myself being a spatial information technology professional, I am now working for a Ministry of Health. So what am I doing here? So in fact, I'm helping the ministry to come understanding the various health disasters. Let us say like recent COVID incidents in Singapore and everywhere else. So it became a big pandemic. So I am helping using this particular tool. I'm helping the ministry to come out with better better insights, to make better decisions, and to identify those risk areas, just to come out with the better strategies to to prevent, for the prevention. And also it can be used for the one of the best surveillance tools and technologies. So next slide, please. So you can see this GIS Service Cloud. This is just one specific example I wanted to showcase. Yeah, I wanted to showcase one specific example here, that here we are talking about you are talking about smart city. You see, in smart city, you're in fact you're referring to your smart hospitals, smart highways, smart factories. Everything is interconnected. There are various the services, sub services within those the domains. They're all interconnected, and for better decision making. So everything is managed on GIS cloud. So everything is managed from efficiently managed from a remote location, where the decision maker is sitting, and he'll be in a position to make appropriate decisions and implement those decisions as appropriately, and they can even pass those orders to the following hierarchies for the implementation. So this it is actually being implemented. if you take example of geo tagging, so maybe, if you take the example of our government services, maybe you're more aware of it. Geo tagging they are talking about, and surveying, and the land record administration, and transportation, and the irrigation, the agriculture. Everything is being maintained and managed through the GIS cloud services. Next slide, please. So yeah, so this particular slide, in this particular slide, I wanted to talk on more on the data for this location intelligence. What is the data? How we already talked about the data and the sources, most importantly, and the services, the kind of services. And here you can see on the left top corner, so the base data, from where it is coming. So most of the times, actually nowadays, so the remote sensing data, which maybe remote sensing data can be from a satellite platform, it can be acquired from a aerial platform, like using drones or aircrafts. So most of the times, what you're getting, the data is from the remote sensing, but it is a dumb image. Remote sensing just remote sensing image is a dumb, in fact you need to convert that into an information ultimately. And apart from that, there are various other sources. Not remote sensing is just one source. So many people they also talk remote sensing, GIS remote sensing, GIS remote sensing. No, spatial information technology is altogether is a different domain. It's much more powerful than just GIS and remote sensing. But there are also different faculties and expert areas. So but in order to manage all this, you need to have those experts readily available for you. So here we're talking about the data sources. So lots of data that we are getting it from the demographic information. We need the survey information, location information, so traffic information, image information, so crowdsourcing, LiDAR, all this information. So we need again, we are using the your computing infrastructure for managing for the processing all this data, and ultimately in a different through different media and platforms, we are delivering it to ultimately to the end customer in different forms. Next slide, please. So typically, this is just just a small representation of how this typical process involved in data integration, modeling, and analysis. So when we talk about the data processing, so you need to collect the data first, and you need to process, and maybe at times you have to interpret and create the data, and you have to model it, or you have to integrate it, and you need to create the thematic. You have to give it a view. Thematic here, it is not about. I'm not talking about map. Don't misunderstood that. Here we are talking about some information, putting that in a different perspective. That is what we call it as what we call as a theme. We are putting that in a specialized perspective, so that we are referring here as a theme. So maybe we need to integrate that with some other information layer, ultimately for better visualization and for better getting some better insights for informed decision making. So next slide, please. So before we actually, so far we have talked about what GIS, the history and everything, and location to some extent we talked about the location intelligence. Now we are going to talk about web distributed GIS. So when we talk about the distributed GIS, we need to talk a little bit about the early stages of GIS, as I already spoken about it. But as I mentioned, actually GIS came into picture as a geographer's or correctly speaking cartographer's tool for automated map making. But then came your vector graphics, right? So which they mostly they called that time, even today they call is a CAD, and it is being used by the civil engineers most of the times. But GIS turned those vector graphics into intelligent objects by assigning some values. So that is properties, values about their property, and that is what we refer as data. Most importantly, and GIS gave them location awareness. That is, making them intelligent in a way, enabling them with the ability to understand the surrounding space and objects. So you just realize how beautiful it is. So it has a capability to understand its surroundings in space. So that's so powerful. So GIS is that, initial GIS. I'm talking about only those days of desktop era. I'm only talking about the desktop era. And in fact, it became popular. That time it became popularized as AM/FM solution. That is automated mapping, because it is produces automated maps. You can make map production process automated, and facility management. You can utilize it in a better way for the facility management. So it was recognized widely as a automated AM/FM solution. And and in fact, that is the real reason why many still carried the rudimentary belief or view that GIS is simply an AM/FM tool. So it is not actually. So then the internet came. So internet has revolutionized from desktop to internet era in 1969. So I'm sorry, there was mistyping there. So in 1969 you have the internet introduced. In 1990, World Wide Web was introduced by Tim Berners-Lee, so whom we consider as the father of the web. So then by 1993, you have the the GIS fast catched up to the web scenario, and it started on web, being on web. So why it chosen be web way? Because of its global reach. It has it can reach large number of users for the better cross platform it can utilize the better class platform functionality, and it becomes very low cost because it becomes accessible to everyone. Then automatically it becomes low cost and easy to use. So the applications are very diverse for that matter. So that's the reason. So next slide, please. So when we when we talk about IT computers and information technology domain, so we cannot just ignore the aspect of evolution of data sharing. So that technology, in fact, that is the basis of for the entire your distributed or WebGIS what we talk about today. In fact, it laid a foundation. And for its advancements in amalgamating all these different diverse technologies into one. And now what we are viewing it as SIT, so Spatial Information Technology today. If I share some of my early experience, those days we used to carry small data like data sets on a as big round disks which has a little space for storage. So now we are talking about the pen drives which has much powerful capability than what those big disks, data storage disks. So slowly their importance those minimized importance has been reduced because of the introduction of the FTP, that is file transfer protocol. So it helped sharing the media and wide distribution of the data over the web, and but then started your HTTP, right? Then it in fact that actually revolutionized the way in which we see the web today. So then it helped the WebGIS grow further. So yeah, next slide, please. So now let's move on to the next the topic, that is evolution of the web the technologies and the system. Let's also pay some attention to how web technologies and system got transformed over a period of time. So you can see here that from initially what we used to have SOAP based protocols, simple object, what we call simple object access protocol, to now we mostly use the REST, representational state transfer it's an architecture. It's not a protocol, it's an architecture. So, and from web services or further extended by the browser side APIs, application programming interfaces, and from three-tier architecture to multi-tier architecture, and from desktop era to the cloud. Now we are on the cloud. We don't need to maintain the computational or the computer infrastructure at home or office. You can utilize the power of the cloud. And now it was early in those early days, so it is only one-way communication. So you have some content shared on web, and the client, you just view that. But now it is two ways. You can put a query or request, you'll get the information in split second of some time. And from wire to wireless, now it is all wireless because of the mobile technologies, and it is more than just mapping. It is not just mapping. Okay, so let's next slide, please. Yeah, as I told you, from if you have a close look at the internet GIS, the basic system architecture, how it looks like. You have multi-tier architecture, as I told you. You have the data tier. In between, you have the logical tier, where you have your GIS server sitting, where your web server also sitting, which is communicating between the client and your GIS, whatever the database, not for that matter GIS, from to the database. And you have the internet in between, which help you through some protocols. It helps you the information reach the client. At client side, on the web browser side, you have the presentation tier, wherein you have the APIs which allow you to view the content in a desired manner. Next slide, please. Now, so I told you that now earlier we maybe not long ago, we were talking about only those websites. Now we today also, till today, we talk about the websites. Actually, they are not websites, they are all web services. So here we have the content shared on web. What actually, it is not just a GIS server, for that matter, any other information technology data server which has the data component, and which has your the processes and the tools, and you have the catalog, the catalogs, which provides creates help you creating those services, and ultimately for sharing over the web. Okay, next slide, please. Yeah, this is just a real world representation. My intention is to show you the real world representation of ultimately what the information looks like. Next slide, please. Yeah, so when we talk about the website to web services, here we need to talk about the scope of the those services. On one hand, we have the browser. Now we have a clear-cut divide between the server and the browser. So we have now widely there are a lot many browser side technologies being used, on APIs being used. So for the processing the data at browser side, in fact. So so server side, what actually happens, it receives the request and send the responses to the client. And what browser side, you can see, you actually request something, and you send response. Okay, receive response. Sorry. And next slide, please. So now, earlier, we were only talking about the three-tier. Now it became the multi-tier. So I have shown you the three-tier architecture earlier. Now it is multi-tier. Here we have different, web service resources. We are all, combining together. In earlier the slide, one of those slides I have shown you by referring when I was talking about the smart city. So in fact, we are talking about we are combining different information layers in the forms of different servers and services. So here also it is the tiers we are talking here are in fact different resources. So you can see here, so they're all integrated together, ultimately combined together to to provide a web browser. In fact, so in a normal day-to-day life, we are not able to see all this. But in fact, whatever the data that we are we are getting access and we are viewing over the web, in fact, it is the combination of different servers, and huge. It has in fact this multi-tier architecture has huge impact on NSDIs, what we call as national spatial data infrastructures, what we simply refer as. So that is a different topic. Okay, next slide please. And so what we generally refer as mashups, all these services as mashups. So here another simple example you can see here. So you have the web server, and which is receiving information from different sources, and which is combining all of those sources, and it is processing all those sources in an automated way in a real time, and ultimately delivering the outcome to the end user for a better or informed decision making. Next slide please. So the mashups, as I told you, the mashups, in fact, actually the term has, it has originated from the music industry, where a song is composed from different existing tracks. So that how it came up. The word came up. In fact, here we are referring that to the combination of different multiple data sources and services. So that is what we call as content aggregation, technically. And it's not just maps. So you see, for example, in the map terminology, here you have a vector layer, and here you have a remote sensing layer. Ultimately, you are combining that to come out with a kind of information layer. So that's what Yeah, next slide, please. So this is one maybe if you just go to any Google Maps website, local maps, any service of the service, you can see a lot of information is being tagged to a specific location. It's in fact, these mashups are not that someone has somebody is sitting out there, someone has specifically doing that job. In fact, this particular data, you are these days, you and me are sharing all this information, and someone is using that information. That is what is Mapshot, the power of the distributed GIS. So all these mashups, what they are doing intelligently, they are combining all this data, being the crowd data, so being shared on the cloud, and it is eventually intelligently it is combining that particular data, specific information, to help you someone else who is requesting for some information, specific information, come out with this much more come out with some better insights. So yeah, next slide please. So what is actually happening behind these mashups, all these mashups? So there are a lot of processes in CRAB. There are geoparsing is happening, technically speaking, and screen scraping is happening. Maybe you being a computer professional, you might be understood what is a screen scraping and the parsing and all. So this is what is behind whatever the information that you're viewing in a pictorial form. Actually, it is all written in a text-based script. Is all scripted. Everything is being converted into digits and scripts, and ultimately helping you come out with a kind of visual information in the form of a map. And you can view the information in the form of a video. You can view in the form of a graph, or you view in the form of a animation, or you can view that in a form of a kind of a service, whatever. So ultimately, these mashups help you come out with giving you some information for a better decision making. So you can see here, GIS application services. You have the base maps already available, and operational layers are they're already available, and lots of tools and information being shared. Next slide, please. So so you have the cloud JS geoportals. Again, as I told you, so this is just an example. A lot of these the geo platforms nowadays, in fact, they are helping like hubs, navels and backbones of the modern day information flows and infrastructure. It is actually they are supporting the information infrastructure that we are using in our everyday life. Whether you talk about the weather forecasting, whether you talk about specific news. Now even a news is being shared. It became very local. You just go to a specific map. You just you will find some interesting news over there on a specific location. You just click on that. You can view the video corresponding to that, and maybe you can even view the analysis or the news of related to that particular news. So it is that as simple as that. So you have the weather content, and you have the whatnot, lots of information, and you can just you can use that cloud already through ready-made tools are already available. So you need to share the information, that whatever that you have, if you think that so some value, you are sharing some valid information. Next. So here, in fact, as I told you, reverse information exchange. The flow is the information flow is it's both ways. And the VGI, we also as I told you, so videos. So actually here the VGI is not a virtual graphic interface. Here I'm referring to VGI is here I'm referring to volunteered geographic information. So that is nothing but it can be a video, it can be something new, some news, as I told you. So it is something that you have notified some kind of incident or event or something which is in your purview, so that you have immediately shared on over the web, so that it can be viewed as a news by someone else who is interested, whoever are interested. So that is volunteer geographic information, we call it as VGI. So that is the information flow is both way, reverse. Okay, it can be a map. It need not be a map information. It can be anything. It can be a picture also. It can be something else also. Yeah. Next. So this is just the kind of tools that are let us say there are some web services that are available. For example, these services they provide you ready-made tools. They come up with some ready-made tools which help you. You need not do any computing. You just whatever the content that you have, they have formatted that the information that needs to be fed into that system. So what you have to do is you have to go there and you just click on that and you feed in that information, whatever that you have. And that's it. It will be shared on the web, over the web, in a desired format, in a click of second. That's it. So that's it. So e-planning, that incident reporting, that's what we call it as. And so now it is, as I told you, it's all the amalgamation of mobile GIS. Let us not even talk about GIS here, but anyway, we are talking about web, web, desktop and mobile. So the different platforms are in fact combined together. and you have lots of development paths are available. Even you need not stick at the specific development path. You have different APIs available, so you can choose depending on your background and your convenience, and you can even come up with your native application. You can add. It is not that hard to develop a specific application. It's as simple as that. If you have some idea and you just use the the knowledge available over web, and that's it. You'll be in a position to develop your own content. Okay, most of them most of them are browser sided, browser based applications. Next. Yeah, so what we are referring browser based applications. So most of them are script based. You can use JavaScript, Python. Okay, they are very popular now. So that is for your iOS applications, that is for IoT, that is Internet of Things. So, and you can even have the access to all your GPS data, other propositional technologies through HTML5. That's it. Next slide, please. So you can see this, native, native or a traditional way of, the applications, we have used it so far. That is, you have the so far some we used to have for collecting the information. You used to carry mobiles or pads for the data collection, and you have the data viewing from client side, and you have the content, everything in traditional applications point of view. The SDKs were like that, but no. In the next slide, please. Here you can see it's much more than just mapping, as I told you. So there are map process and analytical data science, spatial data science tool now available for you. So you can just create your own content. Yeah, you need not focus on the computer, your programming. You can just you focus more on whatever that you want to do, the desired goal, rather than mostly you spend more time on your computer skills, or more time on your programming skills. So you have this all the algebra and statistical analytical tools that are readily available. And now it is becoming slowly it is becoming the spatial data science, what we call today. So mostly, so a lot of analytical, it has lots of analytical power. It gives statistical view of the data. Okay, and you can view, because you can analyze it in a different dimension and perspective. The data you can see that totally in a different scientific perspective, right? Next slide, please. So, but okay, so here we are. So far, we are talking about some the evolution of those technologies, data distribution, and the web technologies and all. And we also, as we grow further, we go into the future. We also face a lot of challenges, and where in fact these are the opportunities where you can focus more in the coming days, and they become your research areas. So security, that is most important thing, the thing that there is a lot of focus being diverted in terms of maintaining the security of all the systems that we are we are developing today. And reliability, that is one important factor. How reliable the content that you are because nowadays we are talking about the mashups. So far we are talking about the mashup. How reliable the content that is being shared on the web, there is a question mark. So that is one thing. You don't know the reliability of the data, and the scalability. So the many technologies, new technologies are coming up, and you are amalgamating all these technologies. And let us say you are coming up with a new requirement tomorrow, and whether we should be in you should be in a position to take this all these technologies combinedly forward. That is a big question mark. Scalability, that is an big issue. And the privacy. So now after this for the last in the last 10 years time, humans have started forgetting about their privacy because of the mobile, because of the on one hand it gives you much power, on the other hand it is limiting your the privacy, and it is narrowing your privacy. That is a big concern actually. So as a human being, so every human being, that is a basic need, as you need a food, and as you need shelter, roof, is also very you need to have a privacy. That is a very essential component. You cannot ignore that aspect. But because of these technologies, the evolution of these technologies, that is being compromised or ignored so far. And you have the data quality issues. There are data quality, intentional or unintentional, whatever. You have the data quality issues, that is as a continuous topic. There are a lot of processes, tools which automatically identify those errors in the data and correct those raise flags for you. But still there is a big concern about the data quality, and there's a big uncertainty about that data. And so as I told you, reliability of the data, here the uncertainty is something, how far it is, you'll be in a position to use it for the important decision making process. That's a big question. Standards and interoperability. So as I told you, so again this is the problem of scalability also. So standards and interoperability, we are coming up with lots and lots of technologies, and lots and lots of every technology follows certain standards. And again, interoperability is a big issue. Interoperability, it means communicating with other technology. So that is a big problem. Semantic interoperability. So of course it is one kind of interoperability. Semantic means reading the other technologies, ability to really understand and read about that. And you have the copyright issues, and you have lots and lots of business models, and your demography is one thing that is a very dynamic in nature. That is actually the data. What you are referring is in a data, as I told you already. So in fact we are talking about the people today. So that is actually the demography. So if you talk about the healthcare, if you talk about banking, if you talk about disaster, whatever, everything is we talk about the disaster management, whatever. So everything we talk about the demography, but that is a very dynamic in nature. You cannot monitor the changes in demography on a day-to-day basis. So that's impossible. So that is a big question mark. So that is limits your ability to understand the scenario in an appropriate way. Next slide, please. So when we talk about when you wanted to share all this the data or whatever the content or the web, the important principle here on the web, how you are representing that's very very important. There you need to follow certain basic principles. So those principles are like for like in many other applications for web map services also, you need to the important priority design goal is you wanted to make that fast, the responsiveness. You wanted to make it very simple. It cannot be a very cumbersome application. It's supposed to be very simple. It is easily understood, and much more very important is it's supposed to be more enjoyable. If it is not for some kind of playfulness or enjoy, if you cannot enjoy that experience, it's people, you are not interested to visiting or viewing that content or data. So you need to make it is more playful and enjoyable. So the experience must be must be enriched with some kind of fun. So that is the basic goal of your your design goal of any application for that matter. Next slide, please. So yeah, there are a lot many technologies being evolved. We are talking about protocols, standards, all these. So you have the catalog services on one hand, you have for the creating services, creating and sharing the services. On the other hand, you have the database services, and you have the server side technologies, and You have on one hand, you have the client side technologies that you're talking about. So this is a universe of different technologies. Next slide, please. So if you so anyway, when you take a close look at a WebGIS service, in fact, because we are talking about the WebGIS now, so that's the reason. So if you take a close look at that services, what you actually see is a client. So that means the user. So user is nothing but a internet browser, in fact, so where you view the content, and you need to have that is internet connection. That is a basic thing. So, and it is very important that you should have an internet connection with with desirable speed, and you have a web server that takes care of your delivering the content over the web, and you need to maintain the metadata, that is your data about your data. Next slide, please. And you have your map server, so which has the capability to handle your your map content, or information in a pictorial in the form of a map, and you have the map viewer. It helps you view the map content in a desirable form. Let us say what would be the extent of your map, and what would be the size, and what is the reference map, and what all this. And other hand, you have you can even define the styling. You can stylize the content. Next slide, please. So okay, we can know you have lot of we so far we are talking about different technologies. So in order to develop all those technologies, you have different development resources available. You have the on commercial. I have listed out those commercial resource, and on the other hand, I have also shared those free resource which are open source. For whether it is operating system, and for a database, and for a spatial database, the RS remote sensing GIS application point of view, and WebGIS development application point of view. So whatever. So I have shared all those details over here. So you can just yeah. So OGC. So when we talk about this, when we talk about web mapping, and we cannot ignore the contribution of OGC, that is that stands for Open Geospatial Consortium. So it was founded in 1994. It is actually a consortium of 346 organization, and this is intended for developing and sharing those standards over the web specifications actually. So they which enable the web map technologies. So interoperability, they takes care of the interoperability issues, and they also help you come up with they come up with protocols to share the content over the web in terms of map service, or like a map. So in fact, this consortium OGC has contributed enormously for developing different technologies and standards. Like as I told you, that is geographic markup language. It is their contribution, GML, what we call, and they also come up with came up with WMS, that is web mapping service, web feature service, web coverage service. We are going to talk about that in the coming slides. We call them as all OpenGIS standards. So web mapping service, we call them as WMS services. So it is actually a service which converts whatever the data that you are sharing on the web, you wanted to share on the web through your map server. It converts that information to an image. Ultimately, the pictorial representation as an image. So it will not allow the cache services. So it provides three important functions for clients to access the functionality, and two functions which are among these two functions are mandatory for implementation. The third function is optional actually. So okay, there are some basic queryable, that is queryable option that you can choose whether you want that or not. Next slide, please. So before we talk more about WMS, these services, we need to talk about the open source services that are available for developing these map services. You have this map server, geo server. All of them are geo server. In fact, it is widely being used. Map server actually, though now it is almost very limitedly that they are using now, after the introduction of this open layers, and now it is leaflet. Now it is catching up. Map bender to some extent, yes. So these are all browser side technologies, yeah. So if you take look at if you look at the web mapping service, so what it does actually, for it has the capabilities, get capabilities. So so it provides the information in term as a layers, in map layers, and get map capabilities, which, and ultimately it generates layers into a convert that layer into a map image ultimately. So, and you can also you can if required, you can also query that data content. Yeah, next. So you can see there are a lot many capabilities it has. You can view that, you can zoom, you can layer. Maybe you are very much familiar. I know that you are very much familiar with Google Maps. So wherein if you wanted to view your particular specific location, so you can navigate through the map, and you have the zoom capabilities available, layer controls available. You can select your layers, and you can even identify that information, or that means identification of the features through some kind of query. And but in this web map service, you cannot select a feature. You cannot do the geo processing, and you cannot query the attribute table, and you cannot use some menus or buttons. It is only just for the mostly for viewing purposes. So in order to for more querying, processing, you have other services available. Next slide, please. Those services, web feature service. So here it is, features means here you are talking about the data features, map data features, which allows you to insert, update, delete, and more editing job. And web coverage services you have, which allows you to create those combining of all this information. So like you are also sharing the information, as I told you, photos, digital, different other models, digital elevation models, and you are sharing this information as a satellite image. So they are from different they represented at a different technology domain. So you need to share that content, interoperability. So WCSC takes care of into all this technicalities. Yeah, next slide, please. So other open source like GeoNode you have, GeoNetwork you have. So this is also widely being used. Next slide, please. As I told you, GeoServer, it is a server is widely being used. Actually, this is a very popular combination. It's a open source, and you can very easy to use. Any layman can just you need to spend some time to understand it. That's it. Even open layers, you can create your own website just by spending some a few hours of time. You can create your own a map service. So that's it. You using GeoServer and open layers. Of course, you have now, as I told you, leaflet is gaining more and more importance nowadays. Next slide, please. Yeah, GeoEdge, as I already mentioned. Again, we cannot ignore the the contribution of PostgreSQL, that is in SRDBMS. So whatever the information that you are sharing on the web, it has a it's supposed to have some spatial component, spatially enabled. If you take the PostgreSQL, it is only a database system. It is just a database system. You need to add PostGIS that enriches you to deal with the spatial data. So the information again it will be stored in the form of tuples, and whatever the tuples and fields only. So records only. So ultimately, everything will be converted into a database form only, information only. But that conversion is being maintained through PostGIS. It has that capabilities. So this is the combination now. Next, please. So future outlook. What next? Going forward. So nowadays, we are on the threshold of Internet of Things, augmented of reality. So this is what I told you already. Augmented reality is going to be the sixth dimension of your computational world, actually, or IT world tomorrow. So it has enormous potential, and I'm sure it is one technology domain that is going to take the world, the technology, the entire it is going to lead all of these technologies forward. So the Internet of Things, you have the drone technology coming up for the data. So, and virtual reality, in fact, it becomes part of, in fact, augmented reality. But now it has emerged as a diversified different domain, and artificial intelligence. So it is actually, again, next, please. So, I'm almost come to a conclusion. So in order to, maybe you are thinking that, you people thinking that, I know that you are from a IT and computers background, as I come to know. So in order to, you all have a chance of becoming a GIS developer, tomorrow's GIS developer. What all that you need to become a GIS developer? So what actually a GIS developer does? So what are the capabilities required, the skills required? So in order to become a GIS developer, you need to have a basic understanding of how to develop a GIS map. So and those application and those geoprocessing tools available, and you should be in a position to understand those client requirements, and you should be in a position to design those applications according to those requirements, and understanding those end user, also you should be in a position to understand the issues which may come up eventually, and you should be in a position to provide the better solutions for those issues. You have to fix those issues in real time. Maybe you, as and when you come up with some new content, you should be you are supposed to give some demos and guide the users by explaining the features of those applications, and provide maintenance and support. Next. So the skills, very important skills that is required to become a GIS developer. So basically, for any, like any other IT professional, you need to have basic understanding of data entry, how to enter a data in a basic spreadsheet form, and the conversion of this data for and putting that in a spatial database system, and maintaining that data, and how to deal with data. That is a basic understanding you should know. So SQL is very, very important. So you should have the basic understanding of your structured query language, and you should be in a position to create a metadata. Whatever the data that you create, is very important that you should maintain the metadata. So when it has been created by whom, with what purpose it has been created, and this is all the information that you have to provide. Otherwise, the data become, one day the data become meaningless and obsolete. So to make this valid, and to take this give the data some life, it is very important that you create metadata when you generate the actual data. Okay. So you should have a basic understanding of what it is. Not that you should have an expert knowledge on this GIS analysis and workflows. At least some basic understanding of GIS. What is GIS? That's very important. So that is enough for you. And model binning. Model binning, it is not just model binning of what it is. Again, I told you that I told you I gave you the example of analytical hierarchy processing. So in order to achieve certain goal, so what are those elements that you need to combine or deduct elements? So it is a kind of algebra. You are putting some implementing some algebra, what needs to be added and what needs to be deleted, what is to be multiplied. These are the things that is we call that as model building. Those information contents to be added together in order to come out with some kind of information, or put some query on this. So this is what is you need to have the basic understanding of this model building process. And cartography, that is, again, you need not have you need not become an expert. Of course, if you there are it is a specialized domain, but that doesn't mean that you have to become a cartographer. So you should have a basic understanding. Ultimately, you are putting all the information map form. So you should have what is a map. You should know what is a map and what is not. How to put a map. You cannot put south in a north direction. So all north always looks towards and all the water bodies should look should be given a blue color. Something is basic knowledge of cartography. And you have to provide some legend. That means understanding of that is the key of your reading your map content. And also, of course, you should have, as I told you, some basic knowledge of your SQL, that is a structured query language, databases, that is very must. And also, as I told you, GIS database, that is PostGIS. So and that is an addition of your SRDBM, RDBMS. This becomes the SRDBMS, Spatial RDBMS. Okay. Next slide, please. So what kind of a task that on a daily day-to-day life that you will do as a GIS developer? So those tasks that you have 4 dimensions. You should be in a position to design and develop GIS applications. It is programming I have mentioned, but programming is not that many. You should have minimum basic programming skill and maintain the software on your own. You cannot depend on someone for maintaining the content and the background. So maybe it is fine that you're from a IT and computers background, absolutely fine. So it is good that you should have some knowledge on GIS, and other related science. And as I told you, programming skill, that is a must, but basic, that is very much required. And data management and basic knowledge on the spatial analysis and algorithms. So salary levels, this is something. Okay, next please. Here you can see the wide range of opportunities you have. It is all that in what direction that you wanted to go, and it all depends on based on your skill, your inclination, your learning ability, and your desire. So based on your life goals, so where is that you can choose your own path in GIS. There are a lot many diversified paths here. You can become a GIS programmer. You can become a GIS database expert. You can become a subject matter expert after a certain point of time later. So or if you want to choose to become an analyst, okay, that is fine. And you can if you wanted to go into a business, if you are more inclined towards a business, business and performing business and taking care of business aspects, so you can become a pre-sales consultant. Later on you can become you become a business development manager. Okay, you can also become a scientist, because you need to have some basic strong analytical background for that. And in order to become a scientist, you need to have a basic understanding of all these areas, knowledge domains. So next slide, please. So here I've given you as I told you, the career path, as I already mentioned. So what is that you wanted to become. So all the interlinks. So you can choose your your path based on your actually first you are, in order to identify your path, it's very important that you should understand your you should understand what you know, that is your strength, and what you don't know, that is very, very important. It's more important actually. Then you understand that where you are lacking, where you cannot go. That's very important. So and it also helps you learn those technology, acquire those knowledge, skills which you don't have. So that's very important. So it's all depending on your as I told you, your background, your skill, and your inclination. So that's very important. So in order to, for example, before you choose any career path, it's very important. These are all technical capabilities we have so far talked about. The very, very important thing is, that is very important thing is your attitude. That plays a major role, especially if we want to work with the corporates in a corporate sector. Attitude is very important. See, I've taken many interviews. So most of the times, what we look in people is the resource is that we don't see how much skill that he has. We only see what kind of attitude that he carries. That's very, very important. So if you have a good attitude, and without a big skill also, you'll be able to improve your knowledge, and you will be able to succeed further. But with a bad attitude but with a great skill, I'm sure it is not taking you anywhere. That's very, very important. The attitude is very important. Your basic reasoning skills, that is very, very important. Reasoning comes with your learning and reading. So this is very important. You need to read every day in order to survive. So this is a very highly competitive world out there. So it is not that it's not going to be that easy. But if you learn how to master the art of hard working, that just it paves a golden path for you. It lays a great path for you for your future. So that's very important. You should imbibe those qualities, reasoning skills that you should have. With reasoning, you'll come, you'll become a good analyst. So that's very, very essential. And your attitude is, as I told you, very important. Attitude is very important, which mostly matters. And you need to read a lot and practice. That's very important. With all that, I conclude here. I think I have only given only 1 hour time, but I'm exceeded my time. I'm sorry for that. Thank you so much to everyone. Maybe this is you can post your queries so that I can answer your queries. Hi, Suvarna. Good afternoon. Yeah, you have any question? It's not need not related to something only this particular topic. You can ask anything. Now that's not a problem. If I know something, I'll try to give some answer. You are free to talk on anything. That's not a problem. Thank you, Lakshmi Garu. Thank you. Yes, of course. What is that we are doing today is, we are monitoring. We are closely working with the Ministry of Health in Singapore. We have already, of course, I cannot reveal that content over here. I cannot share that content because of the some restrictions. So we have come up with some geospatial models. We have presented those models to the ministry, and they are in fact already started implementing that. Maybe we are going to publish that paper. You can share maybe, and also there are a lot of papers out there. In fact, they are research papers. They are published. They have already published. They have started, using this geospatial technologies for mitigating the problem, especially for social effectively implementing these social distancing measures, identifying those crowded areas, identifying those hotspot areas, disease risk areas, depending on the types of population, and those hubs which in a way helps which support this the disease spread. All these things actually you can track, and it is actually a very good, as I told you, it's a very good tool for surveillance, disease surveillance, hotspot identification, cluster identification. Yeah, very good question. Um, it is only because of the reason that I told you in the beginning itself, whatever the data that we are using today, it is all one-dimensional data or zero-dimensional data. We only use data for the purpose of objects and the properties and elements. We have not come to a place wherein we can use this information for making wider. Of course, it is being used widely, but in a limited extent. It is not the potential is not being utilized in a proper way. You will surprise if you come to in Singapore, or for that matter any other developed countries. If you go to any department, whether it is as I told you, whether it is computers, computers department, if you go to architecture department, if you go to some environmental agency, or if you go to any other department for that matter, you cannot find a research project, for that matter any project, without the content of GIS, component of GIS. It is that in wide manner it is being utilized in everywhere. But of course in India it is because of there are the infrastructure matters. Lot of computational infrastructure is not already available. So far GIS was limited to an extent that you need to have a GIS software, and it is very costly, and like that. But now, because of this open source movement, you have the access to all these open source technologies. So it is being used in a wide manner, even in India. I hope I answered your question. Any prediction of earthquakes by? Of course, yeah, it is in geoscience. This is the remote sensing in combination with GIS, in combination with remote sensing, is widely being used for earthquakes and the prediction of earthquakes. You can even predict the earthquakes and those zones, and you can minimize the risk, especially the human the risk to human life. And you can even minimize, of course you cannot minimize the physical damage, but to a large extent you can save the lives. Yeah. Hi Faiz. Yeah, you have a question? Thank you so much for Prasad garu. Any questions? Srinivas garu, Is there any open source projects available to students to work on? Yeah, lot many. Yes. You can, if you just open, you try search for those projects, you will find lot many projects out there, open source projects. So it is not, you're not dependent on someone. Maybe you can take guidance from someone, but internet is your guide for that matter. If you find any difficulty, then you can approach some experts like me. You can come to me or someone else. But you have a lot of content already available, especially developer content. So that's it. It will guide you. It's like teacher for you. So, and there are lots of projects. Absolutely, that's what I told you. It is now gaining more and more importance. Of course, it is in the nascent stages only. So as I told you, there is a lot of potential, especially if you are a GIS developer. It's very difficult to nowadays. It's very difficult to find a proper GIS developer. You understand? The industry is facing a big problem of finding a proper GIS developer. They whatever the developer resource available, they lack all the essential skills. So if you are if you are with a proper skill, there are a lot many opportunities. There is no depth for the opportunities. It's only that your view is limited. That's what I would say. Our view is limited. So we cannot say that there are opportunities. You need to find it. You need to search for those opportunities in the right areas. So definitely you'll find those opportunities. If you wanted to limit to a particular space and a place, it's very difficult. You should be open to you go anywhere, and if you wanted to really start a career, you should be in a position to go somewhere and live somewhere initially. Later on, you can come to a place where you wanted to. Yeah. Oh, Murali Krishna garu again. So, any research going? A lot of research, and so there's a lot of research. Yeah, you can just just type in lots of research projects in terms of environment, in some computation, even in computational sense, in the IT domain. Take any field, as I told you. So there are a lot of research. So that is being carried out. Thank you, Venkateshkar. Thank you so much. Thank you, and thank you so much. Yeah. Thank you, Srinivas. So any other questions? Yeah. So I am going to conclude now. If there is no other question, thank you so much, everyone, for sparing some time out to share some time, your time to listen to my words. I hope this this talk help you to some extent, at least to understand about to some extent understand about the developments in GIS technologies, that's particularly spatial information technologies. So so you can reach me on my email if you want to really need some. Okay, Arvind garu. Thank you, and thanks so much. And thanks so much, Suresh Babu garu, for arranging this lecture. And really, I'm indebted to you for this. Thanks so much. Thanks, everyone. Have a good day.